Good afternoon, Pancha and Livy. Today, I plan to continue a little bit about pandas, okay, because this is related to database. Did you take database subject?
We will take it
next
semester.
Yes, yes. So at least this is like a very minor introduction to that. And then I'll discuss about debugging and catching error and refactoring, okay, unit tests. So this is, I think this is like very important subject. And then next week, we discuss about object-oriented programming. Again, these are very important subject. Okay, let's start. I will go to share my screen. So last meeting, we discussed about pandas, right? Do you still remember?
Yes.
Yes. So the last part is until here, I guess. Okay. I think you helped me in making an insert, right?
Yeah.
Yes, yes. Very good. So a little bit about pandas is that using Panda, you can also make the tables as if they are database. You know, you can merge table. Okay, so if you have two tables, so let's call these tables are left and right, then you can join the two tables into one table. Okay, and there are four types of join. Okay, one is left, right, outer, and inner. So what is that? Using left join, okay, left outer join in SQL. Okay, so you will use the key from the left frame only. If you merge using right, that means right outer join, then you will use the key from the right frame only. Okay? Frame in the table. Now, if you say outer, that means full outer join. That means you will union the keys from both left and right. And then if we say inner, that means you will use intersection of the keys between left and right. Okay, so with this, let's say you have this kind of two tables, very simple table. So let's copy this. And I will open it in Jupyter. Okay, so let's create a new Jupyter notebook. So this is left. So left. Oh, what's wrong here? I forget the import, right? Let's create it. There. So the left table have key column, and then column A and column B. Okay. Next, we also have right table. So, for example, this is our right table. Put right here. There, our right table is this one. So we have key and then C and D. So to combine two tables, you should have at least one column which are having the same name, okay, and values. Okay. Then what happened is now we combine, okay, we merge the two tables. So we have a result here. Now, can you see this? The result of merging left and right table on the key is the name of the columns, right? Then the key will be combined. So by default, Panda merge is an inner join. Okay, that means intersection. So if you look at this, we intersect between the keys, which have K0, K4, K3, and in here we have K0, K1, 2, 3, 4, 5, right? So the intersection will be 0, 3, 4. Now we create a new table, okay, based on inner join. Of course, you can state it explicitly so that you will, if suppose you forget what is the default value, okay, then you can state it explicitly like this. Exactly the same. Okay, the difference is now you stated explicitly that you want to have an inner join. Okay, until here, is there any question? Pancha, Devi, is it clear? You join two tables, left and right, okay, into
Yes.
a table based on certain columns. That column is called key. Of course, the name is not necessarily key. You can name it any columns, okay? This is just to make it simple.
Sir, the
Yes.
column, the left and the right column, it can be different. I mean, the
Yes.
amount of the data is different, right?
Different. You see here, the left table is AD, right? And then the right data is CD, right? So they are not the same. The only thing the same is the key column. So to combine two tables, okay, you need to have a key columns. So it's usually you will have ID as your key, right? So that's why you have, you know, your national ID, KTP. You know, your national ID, the ID on that KTP is represent the key. So using that ID, you can practically search you anywhere.
Okay.
Okay. Now, the next merging is not inner join, but outer join. So the same thing, we copy this, okay? We change this to outer. What is outer join? Outer join mean, so outer join mean you combine two tables based on the union of the keys. Okay, so the key are union, and because we combine both tables while actually there is no values here, then the values will be none for the C and D. Can you see this? Okay. In the inner join, you combine, you string it because you basically you do intersection. In outer join, what you do is you do a union between two tables. Of course, you can also do based on the left table. Okay, so left table is something like this. You see the key here, K0 until K5. Okay, then if we join based on the left, okay, then the result will be based on the left. Okay, K0 until K5. So you see K0 until K5. Now, if you combine based on the right, I will change this based on the right. Okay. now you will get based on the right tables. So until here, is there any question or comment probably? So in principle, you can combine two tables based on certain keys. Okay. Now you can also combine based on more than one key. Okay. So in this example, I can have two keys. Of course, they should have the same name. Okay. So for example, this is left. This is left, and this is right. When you combine, you get the inner join. Okay, merging means you get the inner join. What is the inner join of what? Inner of key 1 and key 2. From the left and the right. Can you see that? So intersection K0 exists, then exists. Okay. K4, in here also K4 exists. Okay, then this one exists. Next is K3. Okay, K3, K2. In here is K3, K0, then not exists. Then there is none in this new table. Next is K4, K1. Exists in the left, exists in the right or not? Oh yes, exists. Then copy here. Can you see that?
Also, it will delete the rows that don't have to.
Yes, it will delete something that is not in the intersection. Okay, not actually delete. It will not show.
Yeah, it will not include the
Yes,
rows.
it will not include. Okay.
Sir,
Yes, please.
I still don't get it. The inner, outer, and right, left, please.
Okay. So do you know set intersection?
No.
No. Okay. So I will, if you don't know, I will put it into whiteboard. Okay. If you have a set, okay, say for example, A, B, C, D, okay, let's call this set A. And then now you have set D, okay, I will call it D, E, C, F, okay. Then I have A intersect B. Do you know what is this?
A, B, C, D, E, A, B, C, D, E.
Okay, I will draw it. If you don't understand, I will draw it. That means this is A, okay? A, and this is B. Okay, intersection is this one. Okay.
So C and D.
Correct, correct. So you have C and D, okay? Now, if I have A union B, what is that?
A or B.
No.
Uh,
Yeah, A or B. That's correct if you put it that way. This one is mean A and B, right?
yes. So
A or B. So what do you have in here?
all of them except C and D.
Yes. So you will have
A,
A, B, C,
E, F,
D, correct?
D, E.
F, okay? But it will not repeat. C, D is not twice, it's only once. Okay? So the same, now this is an array, right? Or a set. So now if you have a table here, let's come back here. So I have this left table and I have this right table, okay? And I want to merge them. So can you see this? Okay, notation was. So this part, okay, this part is left.
Sir, I still see your whiteboard.
Oh, sorry. Okay. Okay. So this part, can you see this? The one that I highlight with blue.
Mm-hmm.
This is left. This part is right. Can you see that?
Yes.
Okay. Now, can you find the intersection of the key? Don't care about A, B, C, D. It's only the key that you think. K0 exists in left, K0 exists in right, correct?
Mm-hmm.
Then you put it here, K0. Okay. How about K1? K1 exists in left, K1 does not exist in right. So don't copy. How about K2? K2 exists in left, but none in right. So you don't copy. How about K3? K3 exists in left, also in right. Twice, in fact. Then you copy. Can you see that? K4 exists in left and also exists in right. So you copy. Okay. How about K5? K5 only exists in left, but not in right. Then no need to copy. So that this is the result of merging inner join. Is it clear? So based on the intersection of the key,
Okay. It's the same with the outer too.
now outer is union. Okay.
Though it's not in the intersection.
Outer is not in the intersection. Okay, let's check outer. Okay, so this,
I think that one, yeah.
okay, this is outer. So this is left, again the same, I just copy back. Okay, and this is right. So if we say outer, what we will do? Check. K0, K0 exists. Yes, put in. K1 left exists, but right not exists. Still copy. Okay, but because not exists, so I will put none. K2 exists in left, but not in right. Still copy. Okay, again, this is none. K3, K3 exists in left, but in right we have 2 times. Then we copy 2 times for each of them. Right? How about K4? K4 exists in left and right, then we copy. How about K5? K5 only exists in left, so we copy, and then the right part will be none. Clear? This is how we do outer join. Okay.
So it's the same, but in inner you don't insert the one that the other table don't have.
Yes. So inner is basically based on the intersection of the key. Outer is based on the union of the key. Right? Now, you can also have left. Here. Left is basically outer join. But, okay, let's see this one. Left is outer join, okay? But now the key is based on the left. The key is based on the left. So whatever in the left, we will put it in. So, okay. So K0, K0 exists, right? K1 exists the same. Okay, K2, be careful with K3. yes, based on the left, which one is K3, but in the right have 2 times K3. Then we copy 2 times here. Even though we base it on the left, but whatever we have in the left and what we have in the right. So why is that so? Because this is outer join. Okay, left outer join, that means you still do union. Can you grasp it?
Yeah.
Yeah. Okay. The same thing now you have right, for example, here. How is right? Okay. So this is left, this is right. What you will do? You will base it on the key on the right table. This one is the right table. With this K0, K4, K3 2 times. So K0, K3 2 times and K4. Right? This is the result. Okay.
Okay.
Okay. Now, if you understand one key, you can extend this to 2 keys, 3 keys, and so on. Okay. So, for example, this is the left, and we have 2 keys. This is the left, this is the right. Okay. And now you use it based on 2 keys, keys 1 and key 2. Then you get the intersection of those 2 keys. Okay. So K0, can you see that the key 1 is capital K, key 2 is a small letter K. Okay. Now K0, what we will do? We will do inner join, right? So then meaning we will have an intersection. K0 and K0 intersect or not? Yes. And we copy. Okay. K1 and K1 here not intersect. Yes, the small key intersect. The key 2 is intersect, but key 1 is not. So it's not. Must be both intersect. Okay. So this one is K1, K1. There is none in here, then none. We will not copy. The same thing with the K2, K2 here is not copy. But how about this? The third one, K3, K0. K3, K0 is not exist in the right, so it's not copy. Okay. So what is K4, K1? Yes, exists in the left, in the right. So we copy that. Okay. So K4, K1. Okay. In fact, we have 2 times. Right. How about K5? K2 is not exist. So then we don't copy. So until here, is it clear? So when you do database, it's basically one of the main tasks is to merge table. Okay. So at least you already know what is inner join, left, right, and outer join. Is it okay with you?
Yes, I
Yeah.
think it's clear.
Clear, yeah? Very good, very good. So the rest is just formatting of the table. So you just copy and paste here, okay, and do it on your own. Okay, so this is not really important, but okay, just to make it nice. So for example, you have this table, okay, and we can color it. So I just put the style here that you can color different color in the table. You can highlight different color again, just to make it nice. Okay. So it's optional. Okay, good. So pandas finish. You still have any question about pandas? Pandas itself is very big, you know. So we just barely touch the surface here. Okay. Anyway, using this, at least you get some introduction. I hope you can still use. in the future. Okay, next, let's do something else. Okay, next is I'm no longer using Jupyter. Okay, next topic is the debugging, refactoring, and unit tests. Okay, so this is more advanced thinking, but using this, you will start to be introduced to what is called test-driven development, and then when we go to OOP, object-oriented programming, and agile later, okay, then you start to see the value of this. Okay, the page is in my website. Again, you go to Python tutorial and you go to debugging and refactoring unit tests. Okay, can you find it?
Yes.
Yes.
Okay, good. So this is based on your question, Levi, last time about can we do debugging using Spider, right? Let me open Spider. Okay, and then I want to extend it to catch error. So in programming, error is very common, isn't it? So by this time, you already familiar with many error, right? So the simplest will be syntax error, right? So syntax error is something that easily cuts by compiler or interpreter of Python. So if you have division or the value of the denomination of division is 0, then you get error, division by 0, right? And if some of your variables or name is undefined, then you get name error. If you combine two different data type, for example, integer you add with string, okay, you will get type error. So all these errors, okay, you can actually cut, right, using this syntax: try, except, else, finally. Okay, using try, okay, at minimum you need to use try and except. Okay. So the statement after try is something that you will run until you catch certain error, meaning that you know there is an error here. Okay. Except, the statement in the except clause here represent that the statement, okay, it will be run when there is an exception error. Now, the else clause here, okay, it will run when there is no exception error in the try clause. And then the finally clause here, it will always run regardless you have error or not. Okay, so, oh, maybe I still use Jupyter. Let's try again using Jupyter. I create a new notebook in Jupyter. Say you have a, let's copy this. What will happen? Oh, there is an error. Why? Why there is an error? It said value error, not enough value to unpack. What does it mean? When you
Oh,
find,
because D only has two objects inside, and
correct,
you define ABC.
correct, correct. Okay, D only have two values, but we put it 3. Okay, so there is an error. Yes, I know there is an error, right? Then I want to remove this error. This error is deliberate, so I want to remove this error. What I will do, okay? what I will do is I put try, right? And then when I put try, exception, yeah, as E, and if there is an error, print E, okay? Print E. So, yes, there is an error, but look, in line one, okay, the program will stop. There's an error, and the program will stop, right? In line 2, there's an error, it will just print there is an error, but the program will continue. Can you see the difference?
Oh, yes.
Okay, so what is the problem? And what is the, okay. If we use this try and accept like this, there's a problem here. The problem is, yes, I know there's an error, right? But I don't know which line make me error, right? So if you want to know which line make me error, so you will type raise. Then it will point, oh, this line number 3 is the error. Okay, when you put raise, okay, when you put raise here, then what happens is it will tell you where is the error and what is the error. It's the same as if you don't put try and accept. So are you confused now? Why we still put try and accept and then still put raise again?
So it tells you the reason why it's error.
Yes, the line number. So raise in here, usually we comment it, right? But if you want to know where, then you uncomment it. During the real program working, you remove this, you comment this. You comment only one line, but the program will not have problems. Okay. So using catching try and accept, okay, the program will run without any error. The raise you put here is just for debugging purposes. Okay, during real runtime, you comment them. Is that clear?
Yes.
Yes. Okay. So you can also change the print in the error. Okay, so if you know what is the error, okay, in this example, you already know that it is a division, right? And then if division is divided by error, okay. For example, divide 1, 0 is clearly 1 divided by 0, right? So there's an exception here. If there's an exception, you created the result. So Z must be 0. If you divide by 0, C is by definition become 0, for example. But you tell them that you just divide by 0. See? So you will get a new result based on your exception. Right? In the else clause here will be printed, okay, when there is no error. Okay, so if there is an error, this line will not be printed. And the last line here, the result is Z. This is always be printed. Okay. If you want to have a full-blown catching error and all the clauses. This is how you do. So until here, is there any question or is it clear?
Sir, I'm still confused about the try and accept, and then we put else there.
Okay, so at minimum, you only use try and accept, right?
Mhm.
And then if there is an error, do this exception. If there is no error, what you will do? Or else clause. Okay. Whether there is an error or not, okay, do the finally clause. Okay. So the purpose of else clause here is if there is an error, okay, to the exception. If there is no error, to the else clause. So in here, you will say, look, I will do this if there is no error. So of course, you can put anything here. Okay, in this case, I'll just print it. The same thing with the finally clause here. You can put anything here. For example, you can add A plus B, for example. Okay, so say A equal 1 and B equal 3. Okay, and I want to print again all this C. And then I want to print C. Okay. Oh, what happened? Why there is an error here? Because divide by 1 and 0. Okay. When we divide 1 and 0, what happened?
Division by 0.
Yes, it will go to the exception. Okay.
Yes.
Okay. And then it will go to directly to the finally. But we never define A. Okay, it will go to the try, this one, it will never go to A. Okay, this is nice case, okay? Let's debug this, okay? I will copy this, I will put it in Spider. Is that okay? Okay, I will close this one, close this one, close this one. I will have a new Spider. Okay. It's not used. Okay, no problem. So let's run this. 1 divided by 0. Okay. What we will do is we use debug, right? Can you see my screen?
Yeah.
Yes.
I go to debug and then set debug.
Mhm.
Okay. And then I will run it line by line here. Okay. It will divide. Okay. Now I go to line 24, right? Can you see the pink color here? Here I will put go inside, step into. Okay. So I will go to step into, and then now I go back to the step in. Okay. In here you see we try. So can you check what is the variable explorer here? X is 1, Y is 0. So then when we step this, okay, what happened? It will call division, 0 division error. Where it will go? There, it will go directly to 0 division error. This line 11 and 12 was not run, correct?
Mhm.
So you know by debugging how Python works, meaning this, when we find an error here in line 10, it will jump to line 13 and skipping line 11 and 12. Can you see that? See? Debugging is a tool so that you will see how Pythons work. Okay, so in this case, you go directly to line 13 and then line 14 now, and then you print division by 0. And then we go directly to line 19 here. We skip line 16 and 17 because this is an else clause, right? So what happened? When I'm in line 19, I'm supposed to have A and B, but A and B was skipped earlier. So if you look at the variable explorer here, there is no A and B. Can you see that? Then it creates another error. So then I will say, oh, unbound local error, variable A reference before assignment. So, okay, Livy, if you have this kind of problem, what you will do?
Mm.
So that you will not have error.
I will change the value of divide.
You will change the value of?
Divide.
You will change the value of divide. With me, I will do is, I will reverse this. Look, yeah. 11 and 12, I will put it up.
Outside try.
No, inside try, they're the same. Look, I'll put it inside try. It's the same, right? The order matter, you see. I will start again, okay? I close this, the debug, you see. This is no longer debugging. Okay, now I debug again. Okay, so I run this. Now I go in here, line 24, and then I go inside. See this? Okay, now I run it step by step. Okay, I go try. What I will do, I will go inside. But at this time, A is defined. A is 1. B is 3. See?
Error.
And then this is error, right? When there is error, exception with this line 13, right? Then Z is 0, right? And then print, right? After that, the else clause is skip, go directly to finally, right? But look at the variable explorer here. A and B are defined. So there is no error. So I got the result. Cool.
Oh, yes.
Can you see that or not? Okay, try on your own.
But sir, so it means there is no difference if you put A and B inside try like this, or if you put A and B like outside try. So divide,
Yeah,
and then like A and B is equal to 1 and 3, and then try.
Okay, actually this is very bad programming practice, okay? Actually, this is very bad programming practice. Never put values inside the code. Okay, this is just for example only, but in reality, you don't put values inside the code like this. This is very bad programming practice. Okay. So what you mean is A and B should be outside like this, right?
Oh, no, it's still inside define, but
outside the try.
Yes.
You put it inside like this.
Yeah.
Yeah,
That would
that's
be the same, right? As you.
it's the same. It will be
yeah.
the same. Correct. This is also correct. There is no problem. But again, a very bad practice if you put values
Yes.
at the code. Okay, values must be outside because this is like magic number. You see, what is A? What is B? Okay, this is magic number. So don't do this. Okay, and this is just an example, but very bad example. Anyway, so let's go back to the notebook. So debugging, okay. The easiest debugging is you print the value, right? I think you already expert in this. So you print the variable value, okay. And next is to use debugger. So in Spider you can instead of step by step, you can go directly to this line. See, you click this, and you see the red color here, red dot in line 12.
Yes.
Yes, that is the highlighter. Okay, so breakpoint, that one. You can also use this breakpoint. So you can remove the breakpoint, you can put it back. Okay, and using this, if you use breakpoint, what you will do is you debug. Okay, it will go directly to breakpoint, right? So when you set breakpoint and then you set debug, it will go directly to breakpoint. Then you will start to see, and then you do step by step after the breakpoint. Okay, so that you will know how the flow of the program run. Okay, so that's the purpose of debugging. So we just cover it here. Okay, there is a step in, step out. So once you finish this, you can just continue until finish. There. Okay, so you can use this toolbar. This is to debug the file, and this is to run line by line. This is to go inside. This is to step out of the code or the module. And this is to continue, and this is to stop. Okay. Okay. Next is the concept of refactoring. Okay. So until here, debugging, catching error. Is there any problem? Pancha, Devi?
No, I think it's clear.
Clear, yeah. You can do debugging, right? I believe you did. Okay. Okay. So a new concept now. What is refactoring? Refactoring means you modify your code, okay, without changing its input and output. Hey, why? Why you need to do refactoring, right? So you want to do modifying the code, make it perfect without changing the input and output. Okay. In our example earlier, oh, I have A and B is 1. Okay. So in that case, I need to change this. Okay. A and B must be in here. A, B, right? And then without changing the input and the output, right? So in that case, divide 1, 0 still there. So I put it like this. This is one example. But this is good because now I know the default value of A and B. Okay. When I run it, the same. I can get C is here. C equal. Okay. So now C equal 3, right? So don't put value inside the code, but you can put value inside the parameter. By putting value inside the parameter like this, you know the default value. Okay. Now, by doing refactoring means you change the internal code without modifying the input and the output. You see this one, divide 1, 0. That is the input is 1, 0. The output is something that you want, which is the result here, right? So again, divide 1, 2, you will get the result is 0.5. So in this example, okay, you can refactor to change the internal structure of the code. Say, for example, you want to change the algorithm, okay, so that your code will work faster, so that it will consume less memory. Okay, that is called refactoring. So you want to get a simple design of your software. So there are several repeating code. Okay, the code that you already put there is repeated several times. Then you refactor, meaning that you simplify. Okay, you simplify the code that you have to make it easier to find the bug. How? If I put it name A, B, X, Y like this, I don't know what is X, I don't know what is Y. I don't know what is A, I don't know what is B, right? Say 1 year later, what is this division about? You don't know. So instead of X and Y, now I refactor, okay? So how to refactor in Spider, there is no special tool. So what you will do is you put replace, yeah? Search and replace here. Okay, so Control R. So X now become numerator, right? So and then you replace all. Oh, okay. If you make mistake, so okay, don't replace all. You replace it one by one. So X. Replace with numerator, find and replace. Yes, not this one. Next. Replace this one. Yes, not this one. Next. Okay, finish. How about Y? What is the meaning of Y there? Y is denominator, right? So, denominator. Okay, so you search, not this one, not this one, not this one. Yes, this one, yes. So replace. Not this one. Yes, this one replace. Okay, so by doing so, now your division become clearer. Okay. Oh, this one means denominator. Okay. Okay. So A and B here is just dummy. So in division we don't have this, right? Okay. Or probably, okay, so we remove C, huh? So come back here. So by doing this, okay, simple refactoring, right? Okay. We change the name. Okay, we change the name of the variables so that easier to find bug. Okay, improve the tolerance to the code. Okay, so that next time you will have clearer understanding about your code. Or you can add some documentation. Okay, for example, here define. Okay, so you put the documentation. You can generate the string. Okay, so division, or I will call it robust division. Okay, so what is the type of the numerator? Real number, right? Okay, for denominator, real number. Okay, there is no description, there is no description. The return value, again, real number. Okay. Can you see this? So by putting documentation, okay, then next time, okay, you will know what to do. So can you type help divide? Is it working? Oh, divide is different. Let's call it, because divide is already inside the module. Can we change it? Okay, I will call it division. Division. Okay. So help. Let's run and help. Division is not defined. Huh. Print. There. Okay. When you print the help division, you get exactly what you commented. Can you see that? So refactoring, one task of refactoring is to create documentation. Why you need to put documentation inside your code? Okay, because you want to reuse your code. One day, okay, say next year, you have another project, then you want to reuse this, but you cannot reuse unless you know what is the input parameter, what is the output, isn't it? Can you get it? So the observable external behavior of your code after refactoring will be exactly the same, but the internal behavior improves. Okay. So what you will do to change, what you will change to refactor, okay, you rename the variable, you rename the method, the module, the class, okay, based on certain coding standard. Instead of ABC, you name it in the correct name, something meaningful. Okay, if you have a long parameter list, you make it simple. Okay, if you have long if, elif, you make it into simple one. Probably you will put into CSV file, or you will put it into database, for example, rather than if, elif, and so. So if you have loop, okay, you can change it into list comprehension. You remember what is list comprehension, right? Pancha, Divi, are you still there?
Yes, sir.
Yes, sir.
So, do you still remember what is list comprehension?
Is it the one that in range 0 to 50, something like that?
So, if you want to create, instead of loop, okay, now you put it into list. I think we discussed it when we do a learning Python. You still remember? List comprehension. There. This one.
Oh, yes. So yeah, so we very much use bracket and then like define it for
Correct.
range.
Yes. Okay. So let's go back here. Okay. So if you have duplicate code, you remove. If you have a global constant, you change it into parameters. Okay. If you have global variables, you change them into variables of the parameters. If you have long parameters, then you change into a simple list. Okay. Say your function have very long, okay, instead of very long parameter, so you put them into one simple list or dictionary. So you understand the meaning of refactoring. or not? Can you grasp? No.
Can you explain it again, sir?
Okay, okay. Refactoring means you want to perfect your code. Okay. If your code have a not so good name, A, B, C, X, like that, so you rename it. If your code is complicated, you make it simple.
Oh, yes. Okay. So it's pretty much like just renaming the variables to for us to understand.
Not just renaming. Okay. Here is the list of things that you need to do.
Yes.
Do refactoring. Can you see it? Okay.
Yes. Okay.
Thing is, of course, renaming, right? Okay. But if you have a long parameter list, your function, okay, have very long function. In the function, you have an input, right? Your input is called parameter, right? Can you see that? Okay, I will put it in my whiteboard. Oh, clear. So suppose you have a function, right? So your input is A, X, B, color, and so on. Okay. So very long. Okay. Then you start to see, oh, the parameter have so many. Okay. So then you simplify. Probably you will just put it as a list. Okay. So the most important is A and X. Okay. And the rest is just the square. Right. Or something like list. So let's put it as a list. So list here. So, okay. So the remaining color and so on, you just put it into that list. So simpler, right? So now you have only 3 parameters. Of course, the list or dictionary. If you don't like list, you can put it into dictionary. Okay, so in here you put it into, for example, in the dictionary, you will put something like in the dictionary input, color equal red, comma, right? B, okay, B represents something equal what? So this one you put it here, so tick. So this is an example of refactoring. Instead of very long parameter, you put it into simpler one.
Oh, okay.
Okay, so next, if you have elif, if elif, in Java is switch, right? Or in C is switch. So in Python we call it if elif, right? Very long. I think Livy enjoyed it, this kind of if elif, very long in your group project.
Yes.
Remember? Yes. So then I said you need to simplify. You put it into CSV. That is refactoring. The code. Okay, the change in the code to make it simple. That is refactoring. Okay. If you have very long loop, then you make it into list comprehension. If you have very long method, then break down the method into reusable method. If you have very long class, then you divide the class into simpler one. Basically, what you do, what is called refactoring, is you change the code to make it simpler, reusable, and easy to maintain.
So if it doesn't have any error, you can
Correct, correct. Exactly. You don't have any error, you still refactor. Okay. Why we refactor? To make your code easier to understand. Okay, easier to find bug. Okay, and the most important is reusable component. Okay, maintenance is important in software. Okay, so when you create the code, you don't create every time you create a code again. You don't do that. So what you will do is you create the code, you make it perfect, so that next time I can reuse. Okay, the term reuse is very important because, oh, this is a nice code. I will put it so that next time I can use it again. So over time, you will have a library of reusable component, right? Something that you can again and again use. This is your asset. Can you understand that? The code that you use, that you make, is not just for one time, but for next time also. Okay? Then you will say, okay, that is only perfecting matter. No. Long time ago, okay, in 1950, 1960, when software was just started, then yes, I don't want to do the very long name. I don't want to do, I will put it very short name, X, A, D, like that. Okay. After that, after 1 year, 2 years, they forget already what is that. So then they create again the same code, okay? But actually it's already done. So it's not efficient, isn't it? So right now, we have what is called agile, okay? Agile means you have what is called test-driven development. Okay, what is test-driven development? The idea is you create the test before you develop the code. What? Right? First time you hear is like crazy. Why you create the test first before you create the code? Say you want to create what is that? The chatbot, right? Then you create the test of the chatbot first before you create the chatbot. You want to create the node, right, Pancha? Right? With the schedule calendar.
Yes.
Right? So then you create the test first before you create that node. It's a crazy idea, right? But this is what is called agile development, okay? So you create a test-driven development, meaning you create the test first before you develop the code. So when you finish creating the test code, then you start to create the function or the class just to pass your own tests. And then what you will do? And then you refactor, you keep improving your test case, okay? Oh, the test case first time is only 2. After that, you add again until 100, until 1000, okay? And then every time you create a new test, then you refactor again, just to pass the test. So then you create a protocol now, okay? First, you need to run all the tests. We call it unit test, okay? And then, of course, need to pass all the tests without error, okay? After that, if you add a unit test, you can add. Yeah, later we talk about how you will create unit tests, okay? After that, you refactor. You increase the understanding of your own code, right? Oh, I improve the name. I rename it so that it's easier to understand. Okay. After that, you run again the unit test, okay? Next, you add again more unit tests to change, modify the main code if necessary, until all tests pass. Then you refactor again. So you see that improving the code, okay, run the unit test. Improving the code, run the unit test. And so on. It's a feedback loop system. Okay, so this test-driven development is very useful technique. Okay, especially if you work in a team. Okay, you don't work alone, right? It's a group. So this is a protocol. Even Microsoft is doing this. Even Google is doing this. If you want to do a big software, you must do this. Okay, so for example, you add certain things in the code. Right? Today, I will do unit test. It's pass. Okay, and then what happened? Okay, after I pass the test, I pass it to my groupmate. Okay, and then he or she make it not pass the unit test. So who's responsible?
Her responsible.
Yes, it's her responsibility. So you break it, you must responsible to fix it until you can pass all the unit tests that already done.
Yes.
Okay, you see, this is how you work in the team. You see that? Okay. Otherwise, you put it back to me. Okay, your code is not pass unit test. Of course, your code is rejected. You will not get paid. With this, you know, I can assign. Okay, my programmer is in Vietnam, in India. All I need to do is to create the text. Okay, and then the input should be this one, the output must be this one. How you make it, I don't care. Now become international cooperation. This is how you manage the software. It's not just coding. Right? Is this something important or not?
Yes, I think it's very important.
Very important. Now you understand. Because this one is creating you money. Okay? Right? This is the actual things. Okay? So, coding, you can pass it to someone else. But the design, okay, creating the test must be you. Right? So, this is higher level, isn't it? Okay. So up to here, tell me, what is refactoring? Why you need refactor? Livy, yeah.
Refactoring is like you develop the code, you construct it so it will be more simple and people will easily understand when see the code, and then if there is if there's a change in the code, by the time we need to refactoring it too. Like there may be some codes that will not be accessed again, so we need to refactoring.
So by this time, I want you to after this, we will discuss about unit tests, right? Okay. So I want you to understand the importance of this. Okay, that unit tests will not work unless you can refactor. Refactoring will not work unless you have a unit test. They are a couple. Okay, fall in love to each other. Okay, we must do both. Okay, cannot just use unit test without refactoring. We cannot just do refactoring without unit test. So both must exist at the same time. Okay, so again, why we need unit tests? Okay, unit tests. What is unit test? Unit test is to test your function, to test your class. There are a lot of tests, including acceptance tests. Okay, so but unit test is like the simplest. Okay, so you do refactoring, then you need the unit test. When you do debugging, again you need unit test. Okay, When you want to add some features, again, you need unit test. Why? Because by adding one feature, say you add one function, okay? And then if you don't have unit test, and then you have an error there, you don't know where is the error come from, isn't it? But if you have unit test, you test first, no error, and then you add that feature, and then you test again, oh, there's an error. Then you know the error comes from that feature. Okay, that is what is called regression error. Okay, regression error means you add one feature in this function, the error is somewhere else. It happens, especially if you keep using global variables. If your code is spaghetti, right? Then it's a nightmare because you don't know where is the error come from. So using unit tests, you keep running the unit test. You run before and then pass it no error. And then you add certain features, right? And then you run again the unit test. Okay. It must pass. If not, then that feature is the culprit of the problem. Okay. When you want to review your code, again, you need unit tests. Okay. So unit test is the requirement for refactoring, debugging, adding feature for your code. Okay. By spending a little more time to define your unit tests, you actually save a lot of time in debugging unnecessary error, right? Caused by modifying your code. Okay. Okay, in Python, how do we make a unit test? Very easy. All you need to do is import unit tests. Okay, and then you can put any class. Okay, you put any class and then you put it unit test case. Just copy this unit test case. The name of the class is up to you, but the name of the parent class here must be this one. Is it clear? And then first you can set up. Okay. Say, for example, I set up ABC. After that, you can create your own test, whatever test you want. Okay. So you can have to make tests. For example, you can assert equal, assert false, assert true. This is the most, there are many others, okay, that you can use in unit tests, but these are the three most important ones. So here, I give example here is, I set up ABC is ABCD, and then test one. Okay, I try to do this code, and I provide the answer, right? So, and then I want to know if the answer is, the answer of asserting this will be equal to my answer or not. Okay. Say, for example, your solution is false, right? And then you need to assert false whether the solution is false. If your solution is true, and then you need to assert true of your solution. Next, to call your class, my test cases, then you just need to do this. You just copy and paste this line of code. When you run it, it will run tests, 3 tests, and then say, okay. That means you're okay.
Sir, are you sharing something? Because I still see your whiteboard.
Yes.
Oh. Oh my goodness. Can you see this now?
Yeah.
Oh, yes. Okay.
Okay. So first you need to import your unit test. Okay. Then you create a class. Okay. Must be inherited from unit test.test case. Until here is okay?
Yes.
Yeah. It's
Okay.
okay.
Okay. After that, you create the test cases, whatever test cases that you create, test 1, test 2, test 3, whatever. Okay. So you can test case of correct value or incorrect value or equal value. Right? Meaning you provide already the answer. You know, like making a quiz. Right? We already multiple choice quiz. So I already make you this is the answer, and then I give you the test, something like that. Okay. So and then after that, after you create the unit test, this is the last one is you to call the unit test. Just copy and paste this line of code. Okay. So then it will run. Let's copy and paste this. I will copy this in Jupyter. So okay, when I copy and paste this, is nothing happened, right? So then I call. Okay, I copy this. I call. Then it will run 3 tests with this test 1, test 2, test 3. Okay, and then said okay. Okay mean pass all the tests. Is it clear or not?
Yes, I think it's clear. Yeah.
So
So we just have to copy that and then like import unit tests.
yes. So now for your practice today, okay, for your practice today, can you calculate can you make a function called factorial? Do you know factorial, right?
Yes.
Okay. Can you get factorial? Can you create a factorial function and then you create a unit test of factorial function? This is your practice today.
Oh, okay. Yes. Okay.
Okay. So factorial is something like this. Okay, I will clean it up. So factorial of 1 is 1, right? Factorial of 2 is 2 times 1 equal 2. Yeah? Factorial of 3 is 3 times 2 times 1 equal 6. Okay? Factorial of 4 is what? 4 times 3 times 2 times 1 equal what? 6 times 4, 24. Okay? So now your practice today is to create this function and the test case. So now the unit test of this. What is the possible error that might happen? Okay. Remember test-driven development. So you need to give me a test first before you create the function. What is the possible error? So this is the test, right?
Yes.
This will be the test, okay? You will 1, 2, 3, 4, okay? Correct. But what is the other test that will be false? Can it test 0?
Yeah, but I think it should be 1. Factorial of 0 should be 1, right?
Okay, then you define factorial of 0. Okay, must be 1. Okay, later you add the test. Can we add factorial of 1.5?
Oh, yes, we cannot do that.
Okay, then it should generate false, right? Okay, not error, you generate false. How about factorial of -3? cannot also, right?
Yeah,
It must be from 0.
from 0 to positive numbers.
Okay, see, now you start to generate the text, isn't it?
Oh, yes.
Cases, okay? Okay, so you create the unit test, okay? Something that true, false, equal, you start to make. Is it clear?
Yes.
Yes, okay. Start now, okay? Livy, is it clear or not?
Yeah.
Okay, so you create the unit test in code.
So now we create the unit test or the code for the factorial.
So test-driven development, meaning you create the unit test first, and then you create the code.
Okay.
Okay? Okay. So I will wait. So I will close the recording. I will pause.
Right.
So it's up to you. You want to use the unit test inside the same code or different code, different module, that's fine. Usually I sub
Separate them.
usually.
Okay.
Yeah. To test, you need to have your own answer already. Okay. Yeah, you can share your screen so that I can help you. Okay, so the way you test is up to you. Okay. So as long as you can test it using unit test, so you can use you can create your own race error handle, like what I just give example, or you can create your own. Yeah. Usually the main problem of perfecting code is if you have a very strange value. For example, what happens if the input is actually string? Okay, okay. So
Then it would be not integer error.
yes, so you see this making a code, okay, is simple. Then you need to think about how to test that code, right? In making the test now, you need to create you need to think, okay, all possible scenarios, what the user will do to your function, including crazy things. You need to be paranoid. Okay. So this is the practice you need to do. Oh, what happened if like this? What will happen is like that. So of course you cannot catch everything, but you catch most of the thing. Okay. And something that not cuts now, that means you will add. So for example, oh, in the past it's already okay, right? This function is robust already. And then suddenly one day you find another error, okay? Because probably some user crazy type anything, right? Then you will add these new things into your unit test. You got it? when you add it to unit test, then your code will over time become more and more perfect. So usually, okay, if you have a range of values, okay, say our case is 0 to 2,500, right? Then you need to test exactly at 0, exactly at 2,500, exactly one before and one after, one before and one after, okay, and then in the middle. So how many tests for one range of value? Okay, 1, 2, 3, 4,
7.
5, 6, 7. Okay, so you need to have at least 7 tests for one range of value in one variable. So if you have 2, then you multiply. A lot of tests you will create. Okay. Yeah, so the most important is, of course, not number 4, but around the boundary. Okay. That's why the test is 2001. Right? Livy, where are you? You want to share your screen also?
Yeah. Okay. Um, So here's my function. And I'm confused how to develop the unit test.
Okay. So where's your function again?
This one.
Oh. Okay, so you use your math factorial. Okay. Now, without using the math, can you create your own factorial? Can you recreate the factorial?
Without using this.
Yes. So, say you create a new file. Okay. Okay. Now you create your own def factorial, for example, or def.
If we use math.factorial, of course it's gonna work, right? Because
Because it's already well tested, right?
yes.
Right. Yeah. Very smart girl. Okay. Factorial of n. Right.
And then factorial is.
I think you don't put space after the factorial between the parentheses. Yes. Okay.
And then
Colon. Correct.
we use if.
If factorial is 1, yes.
And This one.
Equal.
Oh. Oh.
And what?
No. Print. Wait.
Return what? One is one, right? So return one.
Then one.
Else,
One. Even one. Oh. Zero.
one.
Oh.
Oh, zero is also one. Okay. Okay.
Then
What do you want to return?
error. So
You want, okay, raise error.
oh.
Uh, instead of return, you can raise.
Oh. Wait.
Yes. Instead of return, you can raise something. What do you want to raise? What error do you want to say? Error negative.
Error. Yeah.
Okay, you just put error negative. Maybe you can put out of range or
Oh yeah.
of range. Okay. Now you need to create a class. Before the factorial, you need to create a class. Say in line 7, yes, you put class out of range without space. Huh? The name is without space. Okay. Okay, and then you just pass it out of. Can you go to line 7 and then colon and then enter? You press and then pass. PASS. Yes. Okay. Yes, you can raise out of range. You can put the value error in the class. Right, yeah, that one. Value error. Yeah, like that one. Okay, that means inherit from value error. Okay, what else? If not zero, if not one, if not negative.
It can be 2, 3, 4, 5, 6, 7.
Yeah, how do you calculate that?
Or
Okay, you don't like to use the cursor? Range, you mean range, in range.
oh,
And right? Not num. Where is num come from?
1n.
Okay. Okay, and then I think you need to colon. Okay, and then what you will do?
So
That range is from 1, right? Supposed to be 1 until 1. Yeah, okay, 1 until. So then, when x is 1, what you will put? When x is 1, what you will do? And then when x is 2, what you will do? You'll multiply, right?
yeah,
Multiply by what?
multiply by n. 1 by the factorial.
Okay, by factorial.
So,
Put again factorial,
yeah,
multiply x.
multiply it.
Yeah, but in the beginning, factorial must have a value, right?
So I put
Where you will put there.
here.
Okay. What is the factorial value?
The value will be 1.
Okay. Okay, and then
Then
we return that.
return factorial.
Okay. Well, let's test your hmm?
It's not working.
No, you need to put factorial. Oh, you have your test, your unit test?
Not yet.
Oh, not yet. Okay, let's test it manually without the unit test. So can you put in line 21 or 22 part of 1? What will happen?
What? In here, right?
Yes, yes. Print factorial of 1. Parentheses, right? Oh, I think your def is factorial is using F capital.
Oh.
Oh, that's correct already.
So wait.
It will not work if like that because your factorial in the definition must be capital. A while ago, it was correct already. So in line 9,
So
using capital. Okay, you want to put find factorial, it's okay. Okay, and then
capital
line,
yes.
In line 22, what you will do?
Print the factorial.
Yeah, you type factorial of, for example, 2. No. Parenthesis. Right? Parenthesis. Factorial is a function, so factorial of 2. You just remove the equal. It's a function, so factorial of 2, meaning you need to type
Yes.
factorial of 2. No space. Okay. Run. Factorial of 2. Oh, you get 2. It is correct. How about factorial of 3? Okay. How about factorial of 5? Oh, that's correct, right? So your computation is correct, okay, for that number that you just test. So now you created a unit test. Can you create your unit test to?
So, yeah.
That one is okay. It's a separate file is fine, you know.
Oh,
Yes, you just need to save.
so factorial of 0.
So how do you get the LST here? Factorial of 0, then what you will do in here? Okay, you press enter.
I think you have to define what LST and answer is.
Yes, exactly. So you press enter there. And then LST equal
Factorial of 0.
factorial of 0. Being capital, right? Zero.
Capital factorial.
Yes, factorial of 0. Okay.
And the answer I think just change the answer into 1.
Yeah, answer
So
equal
LST
1.
1.
Yeah, answer equal 1. Okay, that's first test. Okay, and then what is the second test? Factorial of
Negative.
negative. So you put -1. Exactly the same. LST equal factorial -1. Yes, you copy everything there. Okay, your answer must be right. So must be error, should be out of range error. So you put assert raise. Raise is S. Yes. So then assert raise is out of range error. What is your class a while ago? You copy your class. That error. Okay, that one out of range.
This one.
Yes, you copy that. Right. And then your factorial This one, the LST now become
And the answer.
no. This is now out of range. Okay, and then there is no answer. There's the answer there. You need to change it to into factorial, your capital factorial. Factorial, and then comma -1. -1. Okay, so line 18, 19, no need.
Sir, can I show you mine
Yes, please, please. Yes,
for a moment? Yes,
please, please.
because I think the time is running out.
Yes, yes.
Yes. So mine work here. Okay.
Wow.
So the import unit test, test float.
Float, yes.
Yes.
Result,
So,
okay.
and then result factorial 10 result is equal to
Yes.
this. I found this on
Yes.
Google.
Okay.
Factorial of 1 result is equal to 1. Factorial 0 result to 0.
Okay, and
Then
negative.
Negative, yes,
Yes.
out of range error.
Very good.
And yes, this is
So
my code.
excellent, Pancha. Excellent.
Oh yeah, if I run it,
Yes. Excellent. So by this one, you can expand if you want. Okay. All other tests that you want to do. For example, test string. Okay.
test string. Oh yes, of course.
For example, yeah.
But if actually if it's not. Oh yes. Oh, we can like add define. You mean like this? Test string,
Function. Yes.
and then function dot assert.
Yes.
It should be raised, right? Assert. Assert.
Assert races.
Assert raise, and then it's also not integer.
Yes, not integer. Error. So again, factorial, and then you
And then
ABC.
oh yeah,
ABC.
ABC.
Okay. With the string.
Yes, with the string.
Okay. The quote.
Wait,
Okay. Run it.
oh, why is it function? Not integer. Oh, sorry. Integer error. Oh. I think it should run. Yes.
Yes. 6. Okay.
Okay.
Okay. Perfect.
Okay. Thank you, sir.
Yes. Very good. So you can read the OOP, object-oriented programming part. We can
Okay.
next week. Okay.
Okay. Thank you, sir.
Thank you.
See you next week.
Yes, you next. Baby, is it okay already?
Oh wait, let me share my screen again. So here.
Okay. So you delete the test 2 and test 3. Okay, and you run it.
Wait.
This one you run. Oh, meaning it's not working.
And this one.
Probably because the untitled 2. So you want to put the name to untitled 2.
Wait.
Or you want to copy that inside your untitled 0.
Okay.
Yes, that one. So put it into untitled 0 at the at the bottom. Yeah. No. Before the main.
Yeah.
Yes. Okay, now you run this. Why it doesn't work? So, unit test. First case. Correct.
Mm.
Do you think because of the space? No, it's correct. Okay. So the prime factorial 5 you remove. Okay, if you run that, what will happen? Oh, not working. Can you debug? And you go inside. Inside. Yes. Go inside. And nothing happened.
Mm-hmm.
Oh, strange. Run 0 test. That means you did not test. That's super strange. Should be no problem.
It's supposed to work right, sir. Because
Yes.
there's no error.
No, there is no error. That is the main problem. Why it is not working? Because you run only 0 tests there. That means it's not working.
Mm.
Okay, let's do it. That from line 9 to line 17, can you put it below the
17.
yes, that one. So you put it Control X.
Control X.
Yes, and then you go to 27, 25 or 26. You go to line 26. You go to line, okay, and then Control V, correct. What happened? When you run this, still 0 tests,
No, not working too.
still not working.
Yes.
All those super strange. Okay, I don't know why it's not working. Unit test. Unit test. Unit test dot test case, correct. That means. Okay, let's remove the argument of unit test main. Just unit test dot main and
This one.
yes, all the. This is because this is only for Jupyter. All until exit force. Exit force you remove. Okay, run. Oh, still not working. What happen if you save it? This is already safe. Okay, and okay, so this is already safe. And it's not working.
Not working.
It's not working. So why?
Mm,
Ah, where it goes? Okay, go there and then next. Yeah, correct. That's one, correct. Next, next, next. Okay, next. And then go inside. Oh, no, this is another module. Go out. No, go out mean this. This one. Yeah, step return. Okay, step return. Okay. Oh, it doesn't test at all. So, let me test one. Why it doesn't work?
In another case, we need to still put test in
Correct.
the.
Only the name of the test should be test something.
Okay.
So I think that is the actual problem.
Okay.
Okay, great.
Okay.
Did you change? Did you change?
Yeah. I just and put a note.
And it works.
Yeah.
Okay,
Yeah.
congratulations. Yay, good.
Okay.
Google helps.
Okay. Thank you, sir.
Okay, see you next week then.
See you.